Hi there, I'm Matthew, and today I'm going to show you how to train models with Oumi. So to get us started, let me show you my environment. I already have Oumi installed, and let's take a look first at the command line interface. So I'm just going to run Oumi train help, and we'll take a look at exactly what is required to run training with Oumi. Now, if you saw my last tutorial, I covered Oumi inference, and Oumi training is very similar. You'll see here that I've run Oumi train and got our help command. We only need to specify a config, and our config is just a path to a local configuration file so we can actually run training. Now, what I'm going to do here is I'm going to kick off a training just so you can see what it looks like. This is going to be a very short toy training just so you can understand how the command works. And then we're going to walk through some configuration so we can understand exactly what is in this config and how does this prescriptively define how training works for Oumi. So you can see here off to the side, I have a few files that I'm going to be using for training, but let's just ls to make sure we're in the right directory. Awesome. We're going to use our quick start just for training since we know this is fast. So let's run Oumi train-c and we'll do our quick start training. Now this quick start specifically is running on SmolLM. This is a 135 million parameter model. It's very small, and I'm only running on a machine that has, I think this is an A100 40 gigabytes, so it's all right in terms of memory. Totally fine for this model. However, we're going to be training in a very short example. This is going to only be training for 10 steps. So this should finish here in just a few seconds. We're actually already halfway done with training while I'm talking. Okay, we have now completed training. So we'll see saving final state, saving final model. Your model has been saved at a very specific location. Awesome. Cool. So we can actually see up here, I do indeed have an output location of this model, and we'll hop into exactly what is saved there in a second. But first, I want to talk about actually how we prescriptively define training using these training configs. So before I jump into exactly what is inside this training config that we ran, let me point you to our documentation. Actually, this is oumi.ai/docs. And we actually have a great section to take a look at here. This will cover things in a little more depth than what I'm going to say. So this is a pointer I'll have down in the description below, but just be aware of it in case you want, a more in-depth view of all the fields I'm not going to cover. So under training, specifically, we can go to training configuration, and this will give us a nice rundown of what training is actually going to look like for us. So let's take a look. We have our training configuration, as I mentioned. Now, our training configuration is going to be broken down into 5 distinct parts, 3 of which you really need to care about. The other 2, they're optional. So specifically, the first piece you want to worry about is the model configuration. Now, the model configuration is going to define exactly what model you're training and how the weights for that model are loaded. Are you going to be doing training from scratch? You're not going to load any weights, just random initialization. Or are you going to actually be doing continued training? You're doing some sort of fine-tuning. The data configuration is going to specify exactly how data is loaded for your model. This is going to have your typical split between the train, the test, validation, as well as how your data is mixed for each of those splits. And of course, the training configuration is where a lot of the hyperparameters for training are actually defined. You can select, first of all, your training loop inside of your training configuration. And you can also then define different parameters about training, where the model is saved itself, and various different hyperparameters we'll talk about here in a minute. The last 2 are, I wouldn't call them niche, I was about to, but they're for different types of training. FSDP is more generic, but we'll talk about parameter efficient fine-tuning first, or PEFT, parameter efficient fine-tuning. Parameter efficient fine-tuning is ways you can train larger models without actually having to load the model fully. This is going to be for things like LoRA tuning or QLoRA tuning, where you want to do adapter tuning for these models. Obviously, this is an optional configuration because maybe you just want to do full fine-tuning instead of actually training an adapter instead. And then FSDP, which is fully sharded data parallel, is a configuration that you can use to use this FSDP system. Specifically, this is how you can load a model that maybe won't fit entirely in one GPU's memory. You can shard it across multiple GPUs. So instead of doing things with DDP, which is distributed data parallel, where each GPU is going to be loading the entire weights every model, FSDP is a way you can handle larger models that wouldn't usually fit in memory. All right, so I gave you a little bit of a high-level overview of what each of these pieces are. Let's take a look at how this looks for the configuration that I ran. So the configuration that I ran, let me pull this over where you can see it, was specifically for quick start training. I mentioned quick start training was SmolLM, and so you can see in the model section, the most important field that I define is going to be our model name. Now the model name functions in two ways. In Oumi, you can specify custom models. So custom models might be a low-level PyTorch model that you've implemented. Maybe you're doing some kind of novel attention, but you want to have a low-level implementation that you've done yourself. If you've implemented a custom Oumi model, you can register that with the Oumi registry. We'll cover this in a separate tutorial, but suffice it to say, if you specify the name of the model you've registered, that model will be loaded. Now, if we can't find a model in the Oumi registry, we will fall back to Hugging Face, and that's exactly what's done here. The model is specified on Hugging Face, and we're going to load weights from there. We also have some parameters you can see here for how the model is actually initialized, different parameters for the weights. Are we actually loading the weights themselves instead of doing random initialization? And then some Hugging Face parameters like trusting remote code for certain layers. The dataset section, there's not much to say here. The most important piece, again, is that, well, we're loading data. We're going to look at our train dataset in this case, or our train split. And inside of our train split, we specify what data we're going to be using. In this case, we have a list of datasets. The list has just one element. We're going to be loading the alpaca cleaned dataset. It's important to note here that the dataset name field is actually exactly like the model name field that was used earlier, insofar as if you have a custom Oumi dataset, maybe your dataset on Hugging Face is messy or the fields don't align properly with most datasets, you can run a custom Oumi dataset to actually parse and properly format this dataset for you. So if you specify a name of a dataset that Oumi has loaded already, it will load the Oumi dataset for you. Otherwise, we will fall back to Hugging Face and load the dataset from there. We also do specify the proper column in the dataset to use. In this case, that is the prompt column to use for training. And of course, the final piece is going to be the actual training configuration. And now let me pop this up really quickly for you here too. We have many different training loops you can use. Right now, I believe we have 5 off the top of my head. I don't want to lie to you, so let me actually pull open our docs and take a look. We know inside the training config, we can take a look at this. And let me actually just use the proper training config field. We can see the trainer type. Here we go. So we have support for out of the box, the Hugging Face training loop, which is just the generic training loop from the Transformers library. The Oumi training loop, this is a custom training loop for Oumi that's implemented in PyTorch with certain optimizations. This is especially useful for the custom Oumi models, which again, we'll talk about later. Then we have various TRL training loops. TRL is the Transformers reinforcement library. So here we have support for the DPO training loop. We have GRPO. And we have the SFT, or Supervised Fine-Tuning Loop, from TRL. So in this example, coming back to our config, we're using the TRL training loop. We're going to make sure we save our final model. This actually isn't something I had to add here. This is the default value of true. I just added it to make sure that you knew that we are indeed saving a model. And we will also save your model additionally every 5 steps is what I've specified. This is obviously not a number you would use in real training, but just for the sake of this example, I wanted to show you that we can save a checkpoint how often as we'd like. So here we're checkpointing every 5 steps. And then how long is the training going to last? Well, we're going to train for 10 steps in this case. That's why our training finished so quickly. We have various different parameters as well here, setting our optimizer and learning rate, setting up our data loaders, and then we have some randomization here of the seed we're going to use, make sure we're actually deterministic here, so we can use our random seed. As well as our telemetry section. Now this is, again, all still under training, but the telemetry pieces are quite important. This is how often we're logging. This is Oumi specific logging, as well as the output that your model is going to go to. This includes the logging that we're actually going to be doing above. This is quite important. You need to know where your model goes. This is definitely a field you want to set, but even more importantly, we have performance metrics, and these are instrumentation that we've done in Oumi that we've found as we train at scale. It's good to know where certain bottlenecks are. So I would recommend enabling performance metrics too, so you can actually see exactly where the metrics, or excuse me, the bottlenecks are in your training loop. Okay, so that said, let's take a look at the output of training. We know that we trained and we should have output to output/SmolLM, 135M, FFT, and we were going to train for 10 steps and save 2 checkpoints. So we take a look at our output, and this is as expected. We see we have 2 checkpoints. It's the checkpoint dash the number of steps. So here we have step 5. That looks right. And let's move this out of the way so you can see better. And then we have checkpoint 10. Again, also looks good. Now, one thing that you should actually note here, and that's quite important, is inside the telemetry directory, we do something that I think is very important. We will save a copy of your training config. Now, you'll notice that your training config here is, it's reasonably sparse. We didn't set too much for the datasets. Models was reasonably short, just a few lines of code here. But if you look at the actual training config that we've saved, it's much more verbose. Now, the reason for this is that there's a lot of default values that are being omitted in this config. We have a lot of intelligent defaults set for Oumi, and you don't need to know about those, at train time, because I don't want you to have to specify a mile-long config. That said, when you want to reproduce experiments, we want to make sure that everything is fully reproducible, that the default that when you ran your experiment is now hard-coded in this config for you. So when you run training, we will actually write to disk all of the default values for this config, and they're specified for you here. So we can see here that we actually have now a training config. Doesn't have all the nice comments that my previous one had, but it is equivalent. It has all the values as they were set at training time, including values that were populated by the default. So this is quite important to know, and this is very important for reproducing your work. Like say maybe you're doing grid search, you're running a lot of very short training runs, you want to find a good setup. We make sure that for each training run you do, it's actually going to specify and save these training configs right next to your checkpoints. That way you don't have to worry about actually going and finding the config you use to run it. It's right there with your saved models. Okay, great. Now I'm going to talk about those 2 additional fields. We did mention that we have the parameter efficient fine tuning section and FSDP. I have a few other configs here that do leverage those. For example, a LoRA tuning config. This config is for tuning, I believe, Llama 7dB. Yeah, Llama 7dB, running LoRA tuning for that. You can see that pretty much everything else is similar. I'm loading my model as expected. I'm loading a similar dataset here, the exact same dataset. I'm going to be running using the exact same trainer, but there is one parameter that's different here. I did set use parameter efficient tuning to true. This, if set to true, means to honor the parameter efficient fine tuning config, which is specified down below, and then to actually use, whatever type of parameter efficient fine tuning I want to use. So we're going to skip past all these other steps. We talked about what these were, and we'll skip to parameter efficient fine tuning. Here you'll see that I have specified different values for LoRA, so I want to actually do LoRA tuning here. Because I've enabled parameter efficient fine tuning, these will be picked up and we'll run LoRA tuning in our config. Coincidentally, I actually didn't intend this for this example, but I'm also running FSDP. So you can see that I have actually enabled FSDP here as well. We have the enable FSDP flag set to true, and then we have different parameters for FSDP set there as well. So there are a few other configs here I have. I'm not going to actually go through them too much more. There's some toy examples you can use, or if you want to, for example, reproduce GPT-2. This is actually a great example from Andrei Karpathy. You can see his initial GitHub link here. There is an easy way to do this in Oumi using the exact same parameters. But we've gone over this already, and this will use a little bit more compute that's outside the scope of this video. So the last thing I will cover then is also vision training. I just want to point this out. We have configs again in the Oumi repo for actually running training on vision. The vision configs are very similar. The main difference you'll note here is you need to specify an actual collator when training, but otherwise everything else should be just about the same as before. Vision does have some special requirements for datasets because the datasets are also formatted differently, so I'd highly recommend taking a look at those. But this config out of the box is a good start for actually tuning Lava. Lava being, one of the reasonable models that can fit on most machines. I think specifically this is the 7B Lava version. Well, and I think that's it for me then for actual tuning with Oumi. Like I said, Oumi tuning is quite straightforward. The command is just Oumi train, and you specify configuration. There's a lot more knobs that I went through to actually run Oumi training. And I do want to reiterate that they're completely and well-defined on the Oumi documentation itself. But I don't want to go through all of them here because we could be here for hours on end. So if you have any questions about this, please do let me know. I'm always happy to talk about this and discuss in the comments about any other things you'd like to see me do. Coming up in future tutorials too, I will be covering actually how to run training in a distributed manner. I did mention like DDP and FSDP, but maybe how do you want to run training in an actual cloud environment, things like that. We will be addressing that because I know most folks don't have a cluster of GPUs at home to run. So, all right, that's it for me. In the meantime, and until next time, happy tuning.